All right, in this video, I'm going to go over IXL section M7, which is constructing the centroid and the orthocenter of a triangle. Kind of like the last two constructions that we did, which was the inscribed circle and the circumscribed circle. They were associated with a specific type of construction that we had learned much earlier in the year. The inscribed circle was associated with the angle bisectors. The circumscribed circle was associated with the perpendicular bisectors of the sides of the triangle. In this one, we're going to construct the centroid and the orthocenter. The centroid is associated with the medians of a triangle, and the orthocenter is associated with the altitudes of a triangle. So we're going to have to be able to construct altitudes and medians of the triangles to be able to construct the centroid and the orthocenter of the triangles. So what I'm going to do is kind of like the last video. I'm going to go to where we're supposed to construct the entire, where we're supposed to go through all the steps ourselves. All right, so this is a good one right here. All we have is the triangle, and we're supposed to construct the centroid. So again, the centroid is associated with the medians. So we have to remember what a median is. A median is a line segment that goes from one of the vertices of the triangle, like A, to the midpoint on the other side. So we got to think, how are we going to construct such a line segment? Well, all we need is to figure out the midpoint of this side. Now, we can get the midpoint of that side by constructing the perpendicular bisector, right? Because not only is it perpendicular, but it also bisects the line segment CB. So if we can construct a perpendicular bisector, then that'll pinpoint for us that exact spot right there where the midpoint, what's going on here? Where the midpoint is. Okay, and then all we got to do is draw a line from A to that point, and then that makes this line segment a median. Okay, and we just have to draw a couple of medians, and then we'll have the centroid, which is the center of the circle. By the way, they're not asking us to construct any circle, they're just asking us to pinpoint the center, the centroid. So let's go ahead and do that here. We have to construct the medians. So what we're going to do is grab the circle tool, make a circle of radius B to C, drop it at C, another circle from C to B, drop it at B, take the line tool and connect the two intersections of these two circles. And then at that spot right there where I'm putting the blue dot on CB, that is the midpoint of line segment BC, or side BC. Let's go ahead and delete these circles, and we can even delete these. Oh no, I can't delete the line. Leave the line there. Okay, now we only have one line. We need to have a second line so we can figure out where the two lines intersect. So what we're going to do is we're going to draw the perpendicular bisector. We have to choose one of the other sides, so let's choose side CA. So I'm going to go to A, draw a circle whose radius goes to C. I'm going to drop that circle at C, take another circle, same radius, but drop it at A. And then we're going to take the line tool, and we're going to connect the two intersections. Let's zoom in here and make sure we don't choose the wrong spot. Okay, there we go. And we're going to delete some of the stuff that we have here, these circles and stuff. Oh yes, I am going to delete the lines because, well, hold on, let me mark this point. So this point right there on CA is the midpoint of CA. So that's what we need. I'm going to delete the lines. Now we can go ahead and draw the medians. So the median on CB is going to be a line segment that goes from A to that midpoint, and the median from B is going to go from B to that midpoint on the other side. So that spot where those two lines intersect, that is the centroid of the triangle. Now the centroid actually has some physical meaning. That would actually be the point on the triangle. That is the center of mass of the triangle. So if you balance the triangle on the pencil, on the tip of a pencil at that spot, theoretically it wouldn't fall down because it's perfectly balanced at that spot. That's actually a physical application of finding the centroid. Okay, so that's it for finding the centroid. Let's see what the next one is. This one is asking us to find the orthocenter. This one is a little bit more involved because the orthocenter is associated with the altitudes. So the altitudes are a little bit tougher to draw. What we need to do is, actually, and part of this, when we were drawing the inscribed angles, when we were drawing the inscribed circles in IXL section U17, at the very end we had to draw a line perpendicular from the in-center down to the sides of the triangle. And it turns out that we have to do that again here. This is how you draw an altitude. So actually, we kind of reviewed this a little bit. So what we're going to do is going to take the circle tool, and what I want to do is I'm going to draw the altitude from A down to side CB. So let's take the circle tool, draw a circle of radius AC, but we're going to drop it at A, center it at A, and those 2 points where the circle crosses, let me just go ahead and highlight that with the drawing tool. So the circle is centered here. These 2 points where they intersect the opposite side, CB, those are going to be the 2 points where we're going to drop 2 new circles to be able to draw the altitude. Shh. So let's go ahead and do that. So we're going to take a circle tool. We're going to go to that intersection point that you're going to see a light blue marker come up there. And we're going to go all the way to point C. And we're going to drop that circle there. Now we're going to do a second circle of the same size. So from C to that point of intersection. But you're going to drop it now at that point of intersection. And then you're going to take the line tool. Well, let's delete the first circle just to remove some of the clutter. So we're going to take the line tool and we're going to connect the intersections of the 2 circles. So right there, and zoom out, please, and right there. Okay, so that is an altitude. What makes it an altitude? If you guys remember, altitudes make 90-degree angles here. So this is 90 degrees. Okay, all right, let's go back to the thing. Now all we have to do is construct one more altitude from one of the other vertices. So let's do from C. Let's construct the altitude from the point C. So let's we're going to go to C, draw a circle. It's got to go to A, but center it at C. And now the 2 places where it intersects the circle. Now this one's a little bit more, I got to zoom in here a little bit because it's kind of hard to see. Let's take a picture of it. So this blue circle intersects the opposite side, AB, at A and at this spot right here. So those 2 spots is where we're going to draw our 2 circles to be able to construct the altitude. So let's go ahead and do that. So let's grab the circle tool. We're going to go to that point A, and to that spot right there, we're going to drop a circle right there. Now, same size radius, it's from that point to A, but center it at A. And now we're going to take the intersections of those 2 little circles that we just drew, the last 2 circles. Matter of fact, let me delete this original old large circle, And let's go ahead and connect the line between the intersections of the 2 circles. Whoops, that's not the one. This one and that one. There we go. Okay, and then let's go ahead and delete everything else. So we're going to delete the 2 circles and some of these dots that we don't need anymore. Okay, so where is the orthocenter? The orthocenter is right there at the intersection of these 2 lines. So we plot a point there, and that's all you have to do to solve this question. You actually have to put the point there. Okay, let's submit it. Okay, we got it right. This is another construction of an orthocenter, but we just did that, so I think that's good enough. What I'm going to do now is go back to when you start at 0, because if you remember from the last one... No, there's enough people in the bathroom. You gotta wait. Excuse me, I'm not done. Shh. No. Shh. Okay, let's go back to 0. So I'll just refresh the page. Okay. So, but look how simple it is. You already have the 2 intersections of the 2 lines. So all you got to do is grab the point tool and put it there. Submit. This one they already gave it to you. Grab the point tool, put it there at the intersection. That is the centroid in this case. Okay, so here, this is where it starts getting harder at 66, or in the 60s. They want you to draw the orthocenter. Remember, that's associated with the altitudes. Now, they've already drawn one of the altitudes for you from C. Your job at this point is to draw another altitude, but from one of the other vertices. So, you know, I guess we could choose, I'm not sure which one would be easier or harder, or which one might cause more of a cluttered mess. Let's just try B and see what happens. So, take the circle tool, go to B. Guys, take the circle tool, go to B. You're going to draw a circle whose radius goes to A, but you're going to center it at B. Okay, and again, we get these 2 points of intersection which are kind of close to each other and hard to see. So we have this point A. So remember what you're looking for. You're looking to see where this circle intersects the opposite side of where the center of the circle is. Okay, so we got that spot right there at A, and we have this spot right here. So those are the 2 places that you're going to use to draw the, to draw the perpendicular line, the altitude. So let's go ahead, grab the circle tool. We're going to go from A to that spot, plot the circle there, from that spot to A, plot the circle there. Then you're going to take the line tool, connect the intersections of the 2 circles, the 2 most recent circles. Okay, let's delete some of this stuff. We don't need the 3 circles anymore. And now you can see where the 2 lines meet in the middle. That is the orthocenter. And we can just submit at that point. Okay, last one. This one is going back to the median, the centroid. They want the centroid. And the centroids, remember, are associated with the medians. Now, they've already gone ahead and drawn one of the medians for you, the one that goes from C to the midpoint of the opposite side, AB. So we have to draw another median. Let's try the median from B to AC. So what we do is we take the circle tool, draw a circle starting from B of radius BA, but we're going to plot it at B. Oh no, I'm sorry, that's not how we do this. Back up. What we need is, let's take out the drawing tool. The median is a line that goes from a vertex to the midpoint on the other side. So what we need is the midpoint that makes this side equal to this side. Well, the perpendicular bisector will do that for us, right? This right here, the perpendicular bisector of line segment AC will give us that midpoint. So the goal here is to construct the perpendicular bisector of that side. So let's go ahead and do that. So let's go to AC and figure out where the midpoint is by drawing the perpendicular bisector. So we go to A, draw a circle from A to C, plot it at C, and take another circle from C to A, plot it at A, and then we're going to take the line tool and we're going to connect the dots between the 2 intersections. So that makes that point right there the midpoint of side AC. Finally, to draw the median, Let's delete some of these things we don't need. We don't need these two circles. We don't need this line anymore because we have the spot. So we're going to take the line segment tool. We're going to draw a line segment from B to that point that we found, the midpoint of AC. And then at the intersection of these two medians, that is the centroid. And that's all you have to do to construct the centroid. Again, the centroid physically means the center of mass of the triangle. So you could theoretically balance the triangle at that point. Okay, so that's it for M7.